Welcome to today's Postgres World webinar, PG Hint Plan, Get the Right Plan Without Surprises. We're joined by Frank Pachou, developer advocate at Yugabyte DB, who will live demo PG Hint Plan, discuss access paths, join order and methods, and how to read an execution plan. And we'll show some examples of how to use PG Hint Plan. My name is Lindsay Hooper. I'm one of the Postgres conference organizers, and I'll be your moderator for this webinar. A little bit about your speaker. So like I said, Frank is a developer advocate for Yugabyte, a PostgreSQL compatible open source distributed SQL database. He's also an Oracle ACE director, an Oracle certified master, an AWS data hero, and an Oak Table member. Welcome. So with that, I'm going to hand it off. Take it away.
Thank you very much, and thank you for organizing that. So welcome everybody. The goal is to talk about PG Hint Plan, something that is not commonly known in Postgres because it's not installed by default, but can be very useful. My goal is to cover quickly why we may use it, but the goal is really to give you the right hints in using it correctly, because some syntax, some behavior is not very easy. And I've seen many people trying PG Hint Plan and just thinking it doesn't work because they didn't have those small tips. So I'm Frank Pachou, I'm developer advocate for Yugabyte DB, and Yugabyte DB is a fork of Postgres. It's basically Postgres used as the query layer, but with a different storage, a distributed storage that can scale out and be resilient and be deployed on premises or the cloud. But the SQL layer is exactly the same as Postgres, which means that this part, PG Hint Plan, is exactly the same. You will see that for the demo, I'm connecting to a Yugabyte database, but exactly the same as Postgres. So about me, the most important is that you can find me easily on LinkedIn, but also Twitter. I'm a lot on Twitter and in many social networks and community Slack also for Yugabyte. The first, I will try to explain why, because some people think they don't need hints. I've been working a lot with other databases. They all have hints because at some point we need them. The way I explain why you may need hints is a SQL database, RDBMS, has an optimizer, a query planner that will find the path to your data. And here you can see on my screen that I have a path. I presented the same in Vienna at the PG Day Austria. So I took this example. When you ask for a path to a destination to Google Map, it gives you one path, that is the one that is in blue there, but with also other alternatives that you see in gray. And you can influence it, give some hints about the real way you want to go to the destination. One way is saying that maybe you prefer car, you prefer public transport. Another way is that maybe you don't want to pay for tolls. And you can choose the mean of transport. You can even drag and drop something if for any reason you don't want to go through one place but to another. And I really compare that to the query planner, to the optimizer. The goal is the same, finding the place to your destination. Of course, the query planner comes with the best way, but you may have more knowledge about your data, more knowledge about how your data model is a bit specific, and then you may want to give some hints in the same idea, maybe not telling exactly to the optimizer what to do, but at least giving more knowledge about what you want. So that's my comparison, why we need hints. And basically, you need it if the query planner doesn't find the best way to access your data. And if it doesn't find, first you need to confirm that what you think that there is a better execution plan. You have to confirm that yours is better, and then you want to try it. So force it with it to try that, and also maybe work around a problem in production. So that's the theory. I will explain quickly the basic things to know about PG in plan, and the goal is to do some demos and have some questions about it. So the big question, why do we need int in SQL? Because SQL is a declarative language. What you write in SQL is the declaration, the description of the result you want. In SQL, it doesn't tell the database how to get to data, just which data you need. So in SQL, you have nothing that can force a specific access path or a specific execution plan. And that's the reason, we will see that's the reason why ints are put in comments, because they cannot be part of a declarative language syntax like SQL. You can see the procedural code that comes from your SQL with execution plan, but with SQL, you cannot force it. Ints play with it through commands. So two reasons why you may want to force something in the execution plan. First, you want to understand the choice, and the best way to understand why the query planner came with a specific plan is to try others and then understand why the others are better or not. And if one is better, if you have a problem in production, even if it's a bug in Postgres and the next release or a patch may fix it, if you have a problem in production, you need a workaround, and ints can be also used as a workaround. The query planner doesn't find the right path. You have no quick solution, maybe a patch or maybe just different way to gather statistics, but you have a problem in production, you want to work around it quickly, and ints can be convenient there. And another reason is just that you know your data better than the optimizer, even if you gather statistics, if you analyze your tables to give more information to the query planner. You may know your data better, like some correlation between data. And also something that is the most important, in my opinion, the optimizer, the query planner, is usually, its goal is usually to find the best plan in terms of the fastest. So the query planner will always try to find a better plan. But actually, users want, of course, they want an execution plan that is correct when you execute the query, that is fast. But most important, users want stable plans. If you have something that works, maybe you don't want to get something better with the risk that it is worse. But that's exactly what the query planner does. If the query planner thinks something is better, it will choose that plan. And maybe you want to stabilize something, like maybe you can do better, but I'm happy with this response time. I don't want it to change. I want predictable performance. So that's also a reason to put ints. Okay, and now how to put it in Postgres. So basically, this picture is, for me, the attitude of the Postgres community when you are talking about ints. I don't know exactly the historical reasons, but in all databases, there are ints because we know that we need them at some point. But in Postgres, there is a community that always has been against it for several reasons that I can understand. But let's be pragmatic. If we need it sometimes to solve problem, we need ints. So basically, how do you get ints? Because it's not in the core of Postgres. Postgres has this beautiful way of adding features through extensions, and PG int plan is an extension. It's an extension that is made and maintained by the Japanese telecom, I think, is entity. And here is a link to install it. I will not go through that. It's quite easy to install an extension. This is just an example in a Docker container how I install it. Just getting it from the latest release that matches the Postgres release and install it with apt-get if you are on Ubuntu. That's really easy with RPM. You can also compile it. The ways to install it is really easy. In Postgres, it's not there by default. In Yugabyte, we just install it by default because we think that it's useful. And it's harmless. I mean, if you don't want to use it, you don't have to use it. But at least if it is installed and one day you need it at the last minute to solve a problem, then it will be there. You will not have to install it later. Okay, and then because the SQL language is declarative, you cannot have hints in there that tells the query planner how to do it. So there are there as commands, and as special commands, we start with a plus sign. So this is basically an example of hints, but we will see more on the syntax and more on the meaning of that. At the beginning of your query, you start with a command /*/ and a plus as the first character, no space, you need a plus there. And then the query planner with the pgint plan extension will read those commands and read them as hints if they follow the right syntax. And then after you have your query, that can be a select, insert, prepare, explain, whatever. And it can be easy if you understand a few things, especially that you rarely need a single hint. This is what I will show in a demo, and this is the big mistake. Sometimes people see an execution plan and think, oh, I want to start with this table or to go by index on this table, and they just put an hint for that. And maybe the hint will not be used because you need usually more hints to force something. We will see that. So I said, this command, you put it at the beginning, and it's probably the best way. If you want to be sure about the rules, you can also put it after the select, for example. Basically, you can put it after any of those series of characters. So not at the end of the query, because you have probably some other signs. Why that? Because, for example, I usually put it at the beginning, so before the select, for example, but when I do an explain, I put the explain before, and explain is just there, so that's fine. Also, you may have some application or some framework or some driver that remove the commands at the beginning, and then you can put that after the select. That works also. We will see also that there is a way to see if the int is used or not, because there are commands. You will not have a syntax error, but pginplant will tell you if it's not used exactly. So be careful. If you have a syntax error in it, pginplant will stop to parse the rest of it. So if you have an error in one int, this int will not be used, and all those that follow will not be used. You cannot nest commands, and the commands are only /* not with the 2 dashes usual commands. If you use prepare statements, you put the hints in the prepare, not in the execute, which makes sense because the goal of prepare is to reuse execution plan. So everything you have to do on the execution plan is on the prepare style, and then you just execute the same plan. And something also to be careful in Postgres, you can run multiple statements in one command, separated with a semicolon. The hints are read at the beginning of the command. So be careful if you use that. You put all hints at the beginning. And something also a bit tricky, from PSQL, the command line of Postgres, if you use a semicolon, PSQL will send them as multiple commands. If you backslash it, it will be one. Be careful with that. I just mentioned it because those are a few tricks. You probably will not have problem with that. And I don't think you use a lot of multiple statement commands in application, because that's not easy when you look at them in a PG stat activity, or better use one command per statement. Okay, and something also very important to understand, the ints usually reference the table, like I want to start with this table, or I want to go through index for this table, but actually it's not the table that you reference, it's the alias in the query, because you may read multiple times the same table, and but there are different aliases. So always aliases there. And it's easy because in the execution plan, and we will see it, you can see the alias. So even if you have the table name in the from clause without an alias, the alias will be the same. So if you have a doubt, you explain, and then you will see it. We will see that in the demo. Case sensitivity for them is a bit different from SQL, because in the ints, the aliases are case sensitive, even if you don't put double quotes. But if you have special character, you need those double quotes. So just take them from the explain and copy paste, and we will have the same. And probably the most important, we will see that in the demo, is that when you have a list in parentheses, the order is not important, it's not used. So we will see what means hash join A, B, C. It just means that you want to hash join when you join A, B, and C without any order, without mentioning by which one you start. So this int is the same as this one. When there is a need to mention an order, and it is in the leading int that will really define in which order the tables are joined, and the order and the direction, because even if you have two tables, you can start with one to go to the other, or the opposite. When the order and the direction is important, you will have pairs of parentheses like this. We will see the example. Those are different. This one says start by joining B to C, and A will be joined to the result of this join between B to C, where the other one will start with A to B and then will join to C. It will be easier in an example, but those are all the little tricks where if you don't know them, you will try to int your query because you need to understand something or to work on something, and you will see that it doesn't work. It's just because there are some tricky syntaxes. If you have a doubt, there is a way to troubleshoot and see more information about syntax error, for example. So by default, you will see a mention that there is a syntax error in your int. And you can see also more info. We will see it by setting PG plan in verbose mode, where you will have a message telling you which ints are used. So then you know that they are really considered by PG plan. If they seem not to be used, they are considered, but maybe they didn't apply in that case. And if you want those messages to be on your in your session rather than in the log, you can set client min message to log. Okay, and last point about those basic recommendations before using ints. What does an int? Int doesn't force anything. There is nothing like forcing the query planner to use an index. The ints, like their name int is saying, are just giving some hint on what will be considered by the query planner. So basically, if you say, go through index for this table, it will be more like do not consider the other possibilities except if you have no choice. And basically what it does, it sets high cost for the path that you don't want. So basically, if you say go through index for that table, it will just artificially put a very high number on the cost of the non-index access path. So yeah, I see in the chat. So not force, more like an advice. But yeah, it puts high cost, and then that means that if the plan that you want is possible, it will be taken. But if it's not possible, another one will be taken with high cost. But if there is no other possibilities, it will come with a plan. And if you look at the Postgres code, you will see that this artificially big cost is there as a constant. Okay, I went through all that. The goal also, we will provide the slide. The goal is that you have that as a reference, but better go for a demo. And especially during the demo, if you have questions, just ask in the chat and we look at it. So we will see how to define join order, join direction, the different method, and some many things that can be done in addition to that. So here is my demo screen. Maybe I will just put it a bit larger. Should be okay, but always better to have large fonts. I'm connected to Yugabyte, which this version is just Postgres 11.2 compatible. And I have pgin plan installed by default there. I create 3 tables. Looking at the chart, yeah, okay. So the size of the font is okay. I create 3 tables, and I will run a very simple query. I want especially to show the join order, and then with 3 tables, it is easier. So let me explain a query that will join those 3 tables. Select star from C, join to B, join to A. And 2 things. I'm using, where is it? I'm using a natural join here just to get it short, easier to show the demo. You probably don't want to use natural join, especially because the columns may change in the tables. I use that to have the focus on what I want to show there without more text. And I use aliases to enforce the fact that ints use aliases, and to make it smarter, I used Unicode characters with fruits. So C is cherry here, B is banana, A is apple. Again, do whatever you want. The goal is more for the demo. I don't really put apples in my queries in production. So when I explain this query, the Postgres query planner decides to scan first C and do an hash join to B, where B is the hash table, and then do nested loops for each row from this first join will go to table A. So you see, whatever the way you write it in the from clause doesn't matter, and the query planner comes with its own choice based on the cost. Again, I don't show cost. It's just not to put too many things in the screen for the demo, but you can check the cost. It's there by default. So now let's say that I want to force a different join order, because that's usually the most important. Basically, I will simplify things, but basically the best execution plan is usually starting with the most selective column and then joining to the tables that do not increase the number of rows. So usually to the parent tables, the lookup tables, and then at the end, those that may add more rows, more detail. Why? Just because you want to start with not many rows and and not have to work on many rows through the joins. So the join order is usually the most important in an execution plan, at least the first thing to look at. So let's say that I want to force an order of tables with the leading int. So the leading says which one is first and then put them in the order. And so the same here with just leading it, and I use aliases. Again, the aliases, if you don't know, just take them from the execution plan. So here I didn't use the quotes because you don't need to. That's different from SQL, but you can put quotes also. I just take them from there. So here my plan is different. Before I had cherry to banana to apple, now I have apple, banana to apple, and then to cherry. So my int did something, but not really what I wanted, because I wanted apple to banana and to cherry, but I have banana to apple. And this is what I mentioned before, when you don't have additional parentheses for the pairs of aliases, the order is used, but the direction can be changed by the query planner. Here, my int tells to the query planner, consider first apple and then banana. So this is what it did. The first join is a join between apple and banana. But then it came with another direction because the query planner thinks it is better to hash A rather than B. And then go to cherry. So leading it did something, but not completely deciding the order of joins, just the order where the tables will be looked at by the query planner. If you want, something else also to mention, if I add a hash join with apple and banana, this just says when you join apple and banana, use a hash join, which is already the case there, but doesn't define the order. There is no order in the join method ints. The order is only in the leading with nested parentheses. So this is, I run it on that, explain. This is the right leading int if you really want to define the order and the direction. I want apple to be joined, so to be the first one in the execution plan, then join to banana. And here I have apple first and then banana. And because I say this must always be a hash join, the second operation of the hash join is always the hashed one. So by saying hash join between apple and banana, and by forcing the direction of them, just saying we start with that and we force the direction, I know exactly that banana will be the hash table that will be put in memory. And that's important because if you are joining a big table with a medium table, hash join is probably what will be chosen by the query planner, and you want the smaller one to be the hashed one because it has to be hashed, that's CPU, and it fits in memory. So that's important. Usually this choice is done by the query planner because it estimates the number of rows, then it estimates the size, and then it estimates the cost. But if for whatever reason, because there are complex queries, if the cost and the number of rows was not correctly estimated, then the query planner may be wrong, and you may want to see what happens if you use the other one as the hash table. Okay, so that's the most important to remember when you want to fully int the joins. You need leading to say in which order, but with pairs of parentheses to mention in which direction. And then the join method, because if you only say this, it can decide to use a nested loop between apple and banana here. Okay, now let's say I want more control on the join method, because when you decide to start with a table, the join method will be important. So if you just int for the join order, but let's imagine you int for the join order because you know that you have a lot of rows, but finally with that, the query planner comes with a nested loop on a lot of rows. That can be expensive. So let's say that I want also hash join instead of a nested loop there. This is the full inting that I will do. So I run it and we will see it. So still considering the same tables in same order and same direction. The first one is apple and banana. And I want a hash join for apple and banana. And then the second join is a join when we have apple, banana, and cherry. And this is how I tell that. This doesn't define any join order. This just say when the query planner is at a step where the tables were apple, banana, and cherry, then use hash join there. So you see that I have only 3 tables. And if I want to force exactly the join order, direction, and method, I need those leading, and I need a method with 2 aliases and a method with 3 aliases. You can imagine the complexity. And if you put only one, you may be lucky and see the right plant and stop like thinking that your int was used because you have the right plant. But then one day, the query planner may come with another order and then it will not work. So if you want to int to get stable plan, and if you want to int to be sure that this plan is used until maybe you fix something else, then you need all of them. That's the most important to remember. Those are only about join methods and order, but here you can see that the query planner decided to do a sequential scan on A, and on B, and on C, and doesn't depend on int. Of course, it will choose the cheaper for this join order, but you can also have control on that. And this is, for example, where I just add an index only scan on banana because I want to force an index. But you can see that I didn't force anything. And I didn't show it there, but if I, excuse me, if I show the cost, you will see that the I cost, let me put it there. Should have done that before. Yeah. So you can see what happened there with my index only int. Actually, it cannot use an index only scan for this access. It cannot because I'm reading more columns than what are in the index. So my int was not ignored. It was just that it has set a high cost for other operations. So basically for the sex scan on banana, a very high cost. But because there is no alternative, because the index only scan is not possible, this plan is still used. Now, if I create an index where index only scan can be done, I'm querying by colon X, and I also select N. So if I use the same ints as before, with index only scan, here I can see an index only scan. Just because now it is possible. And that's also another reason, another case where I will use int. If I think it would be better to use my index, but I see that the query planner doesn't come with this index. I want to know if the index is possible, but not chosen by the query planner, or if the index is just not possible. And by putting it, I can see that. If I int for the index and it's not used, but with high cost, then it's probably because this index cannot be used. And then I will look at its definition, if it is valid and all that. If by forcing with an int, the index is used, then I know it was a cost-based decision. It's not an impossibility. And then I will look at the statistics at the estimation. So ints are also a good tool in troubleshooting to understand what happened. Okay, and then if I want, just to show you that if I want really to fix this exact plan, to be sure that it cannot come with something else, because for example, one day the query planner may decide to go through index on Apple because a new index is created or because the data distribution has changed. If I want to fix exactly that, those are my full ints to get exactly this plan. We have seen that with those, I fully int the join order and direction and scan methods. And for each table that is accessed, each alias, I define how the scan method, sequential scan for apple, index only scan for banana, sequential scan for cherry. So you can see how it's not so easy when you want to force a plan. You need a lot of hints, but there is no magic. You need a lot, but it's easy to understand when you know how it works. If you have any question, put them in the chat or we can look at them later. I have more content, will depend on your questions. I will go back to the slides
No
and show you.
questions
No question for the
as of
moment,
yet.
perfect. But by this way, all our costs are not good anymore. Yeah, that's a good remark. When you int, the cost is not really useful because you force something else. And usually when you int, it's because the cost is not evaluated correctly. And that's also the reason why if you int only partially, this is where you will have problem because you int something partially, but then there is still a cost-based decision for the other part of the plan, and then the cost may be bad. So if I put in and I want them to be deterministic, I will probably put enough int so that then the cost is not used by the query planner because it may come to something that I don't need. And again, ints are workarounds or way to investigate a problem. Do not put ints in all your thousands of queries in the application just because it will not be maintainable. And also, if you put an int to work around a bug in the query planner, look at it again when you patch or upgrade. Maybe you don't need it anymore. Okay, there is another question. Any plan to make the syntax close to the Oracle's int syntax? I don't think so. For two reasons. First, because the optimizer is different than Oracle, so there are different things. And also PGInt plan is maintained mainly by a company for their needs. And there is also another thing. If you start to come with ideas to do the same as Oracle, you will have less chances to get it in the Postgres kernel because usually people don't like to do like Oracle. Yeah, you can do a lot more with ints in Oracle just because it's there for a long time. But basically, PGInt plan is quite useful on many things. And let me show you a few things that we can do. Yeah, just before, but it's more as a reference. I don't want to remember that. We have seen the case for 3 tables that we need leading with 2 nested pairs of parentheses and 2 join methods. If it's not 3 tables, but n, you will have n minus 1 nested pairs in leading. For each pair, you will have a join method. The join method, the first one will have 2, the second will have 3, up to n aliases. And then because you have n aliases, if you want to force the access path to them, you will have n scan methods. So basically, if you want to be sure that you have fully hinted a plan, rather than looking at the plan because you may just be lucky, you count the parentheses. And if you found 6 times n minus 2 closing parentheses, or you can count the opening because of course they need to be balanced. Then if you have this number, probably you have fully entered the join method, direction, order, and access path to each of them. Just keep that in the slides when you need it to be sure. And something else that we can do with ints. So those were really about hinting the access path to the data. But you can do something more clever, because usually if the plan is not good, it is because the estimation on the selectivity was not good. Postgres is quite good at estimating the cardinality, the number of rows for a simple predicate. Even if you have complex predicates with extended statistics, it can get the good estimation. But when you join, after each join, the margin of error increases. And on complex query, there is a point where the selectivity estimation is unknown, especially if there is a correlation. The example I take usually is, imagine you have a table with countries and a table with cities. If you query with a where clause and you say where country is US and city is New York, the query planner will look at the selectivity of US within the 300 countries, and then we'll multiply that with the selectivity of New York within the, I don't know, thousands of cities in the world, without knowing that if it's New York, it's probably US. So if you want to give more information, there is a hint that can give more information about the cardinality, and instead of forcing something, we'll tell the query planner, when you join A to B, whatever is your estimation, replace it with this number. And even better, you can apply a factor. When you join A, B, and C together, whatever the order, if you come with an estimation of 100 rows, just take 1/3 of it, because you know that there is a correlation in data that usually makes it overestimated. So this is a way, without forcing something and without even forcing number, to just give more information about the selectivity after joins. And other thing that is handy, not critical, but that can be handy, you can set parameters. You know that you can set parameters for a user, for a database, for a session, even for a transaction with set local. But if you want to set a parameter only for one query and be sure that you don't have the risk to forget to revert back to the previous value, you can set a parameter within a statement with a int. So this sets join collapse limit to 1. And I take this example of join collapse limits because if you don't have int, setting join collapse limits can be a way to force a kind of order between the tables, because it will consider the tables in the order they are in the from clause, but not with the direction, not all that. And just mentioning that, kind of, if you know Oracle, kind of the order int in Oracle. But basically, any query planner parameter, for example, you may want, you know that your query will do read data that is mostly in cache or not in cache at that time, and then you may want to change the cost estimation for sequential scan and random scan. You can do that at query level. Always better when you have a workaround, always better to put it at the same scope as the problem. If you have a problem with a query, do not set a parameter for the whole database. And this is where you can put it as an int in a query. And also, ints are comments within the query, but you can have later, just after it, real comments. And usually, if I put an int, I will put a comment with the reason of my int so that my next colleague or maybe myself after a few years, I know why the int was added and I can evaluate if it's still needed. Okay, and I'm looking at the time, I'm looking at the questions. So everything that we have seen helps you to, for something in the planner, when you can rewrite the query. So when it's your troubleshooting on lab where you want to test something, that's fine. If it's a workaround in production, maybe you don't want to change the query and release all the application, or just maybe you cannot because you don't have the use an application where you cannot change the code. And then you can put the ints in the table so that they are used automatically for a specific query. And I see that there is a question. I will answer the question just later. So how do you do that? You need to create the extension. For Pidgin plan, you need to have it in the loaded libraries. If you want to use the Pidgin plan table, you need to create the extension. And then this is how it works. You insert into a table that it's called in-plan ints. You insert a row with the query that you want to be inted and the int that you want to be automatically added when this query is used. So you have a query, you know it, but you cannot change it from the application. You put it in that table and you put the int that you want. And you have even more control. You can use the application name that you can set if you want, for example, to int only for the reporting use case and you want to be sure that you have no regression on the OLTP one, for example. And something important, when you have queries with literal values in it, you don't want to int all different values. So either you use prepared statement and you have parameters, and that's fine. But if there are values, literals that are not parameters, you just replace them with a question mark there. So you put a template and it will be used automatically. So that again can be a workaround. If you have thousands of queries in this table, then probably you lost control on that. But if you have 2 or 3 reporting that are too complex for the query planner, you know, when you join more than 8 tables in Postgres, the query planner is switching to another optimizer and may do some mistakes. So for the reporting, you can force something there and keep it in control, document it, and look at it. So there was a question about when you use common table expression with the with statement and multiple selects. The ints, that's different from Oracle, where you can put ints in subselects. Here, all the ints go at the beginning of the command. And even if you have multiple statements, the ints are all at the beginning of the command. So hopefully, if you have multiple subselect, they have different aliases. And maybe I have an example I can show you quickly. If I have an example, so I had an example with set, but we will skip that. You have the slides. I think I have or not. Sorry, I thought I had an example. I don't, but I will explain it. You see the alias in the execution plan. Sometimes you have a subselect that has no alias. But in the execution plan, you will see a special alias. I think I have a blog post about that. I don't remember exactly the name. So the alias maybe, yeah, for a CTU, for a common table expression, the aliases will be different. but you may have cases where the alias is not in your query, but you will see it in the execution plan. And so do an explain, check the aliases and use those. Okay, and yeah, if the query is complex, there can be cases where it's difficult to int. This extension has been done by a company to solve their problems, and they evolve it when they find their problem. It's on GitHub. You can also create an issue. They have community support for that. So when you use this in table, you insert them and you enable it. It's not enabled by default because it can change the thing. You need to have full control about it. Important to understand that there can be a prepared statement in it. There can be question marks for literals, and there is no semicolon on it. Okay, that's what I have there. You have all information about it. I will see I upload the slides because the slides with reference. In my blog, I have a few blog posts about it. Let me check quickly if I find it. So I blog on Dev2. And then if I Google Dev2 my name and PG in plan, I should find, yeah, for example, this answers the question about subqueries. Just want to show you. So that's exactly that answers the question. There is a city. Here I have an insert and a common table expression. And if you explain it, you can see here an alias, any subquery. That is actually the subquery that is there. I didn't put any alias for it, but the query planner puts it to recognize the different parts. So you can see a subquery scan and that. And because it is an alias that you can see in the plan, you can use it in the int. So don't try to guess, check the execution plan, and you know exactly the name of the alias that you have to put in the int, and copy paste is the best way to avoid the typos there. So whatever the alias you put, if there is some ambiguity, look at the execution plan and maybe you can do that. Okay, do you have any more questions?
So I think you've answered them pretty well as they've come in, but
Yeah.
another one right now. With subqueries, do all aliases have to be different?
I'm not completely sure, but I think that they will be different in the execution plan because at some point the query planner must identify it. I don't have an example in mind. So on one side, I think that they will have a different one in the execution plan, and this is what will be used by PG in plan. But there are probably some complex query that you cannot int, because it's still something that is added on top of the query planner, and maybe some special cases are not there. I'm not sure it is a big problem because anyway, ints are already something that you don't want to do for all queries. It's specific, and then probably even if you cannot int everything, probably it's good enough for when you want it.
Okay, wonderful. Any other questions? Let's give folks another moment here. And while they do, I just want to say thank you so much. This has been a wonderful presentation.
Thank you.
So I don't see any other questions coming in. And we can bring it home then. So thank you. Thank you to all of our attendees for spending a little bit of your day with us. And we hope to see you on future Postgres World webinars. Cheers and have a great rest of your day.
Thanks a lot. Bye.